Michel-Yves said, the question of the existence of God is indeed a fundamental and passionate issue. And our goal in this book that you had was to try to summarize as much as we can all the available knowledge in this matter, in philosophy, morality, and history, but above all in science, because this field is particularly interesting as we have been witnessing what we call a great reversal. This great reversal is that for 4 centuries, from Copernicus to Freud, via Galileo, Newton, Laplace, and Darwin, science seems to be able to explain the world without the need for the hypothesis of God. And by the end of this, Marx and Freud, who claimed to be scientists, even tried to make people believe that religion was toxic and that it was the opium of the people. All of this led to a very powerful materialist and scientific intellectual current that dominated the past. But over the last 150 years, slowly but surely, things began to change. A series of scientific revolutions seems to converge into 3 key facts. The first one is, as Einstein demonstrated, we live in what we call a space-time, where space, time, and matter are inextricably linked, and you cannot imagine one without the 2 others. Second, we have strong reasons to believe, as Michel-Yves said, that there is an absolute beginning. It's very interesting because this absolute beginning is not only the beginning of time and matter, it's also the beginning of space, as Georges Lemaitre note from the beginning. Before, if we can say, there was no space. And of course, it has immense metaphysical implications. And third, we also discovered that our universe is extraordinarily fine-tuned in all its parameters. We are speaking of the initial data of the universe, the value and ratio of the 4 forces, and all the laws of quantum mechanics, physics, chemistry, and biology. All this is incredibly adjusted and calibrated. And we detail this in our book, but the question is, what can we deduce from this? How can we think about this? In fact, to keep it simple, we can say that if time, space, and matter are the beginning, the cause of this emergence is by definition outside time, outside space, and outside matter. It's transcendent. And it has the power to create everything and to adjust and calibrate everything. So when we are speaking of this, we are speaking of the beginning. In fact, the cause is non-spatial, non-temporal, non-material, and create everything, adjust everything, in order that complex life could occur. When you are saying this, you are saying that you are very, it's quite the same of the basic definition of God in all philosophy and or religion in the past. So that is to say, a transcendent being outside the universe who created and adjusted everything so that humanity and all life could one day come into being. So we can say that God is a possibility, but what are the alternatives? To find it, there is 2 problems to try to explain without invoking God. The first one is beginning, the second one is the fine-tuning. Regarding fine-tuning, as we said, the solution was the theory of multiverse. But this theory has 4 problems. First, it's 100% speculative and unfalsifiable. Second, it has difficulty explaining beauty and harmony that is present everywhere in our universe. Third, to be coherent with the extreme improbability implied by fine-tuning, we would have to postulate, as we said, truly staggering numbers of universes. The string theory, today we spoke a lot of 10 to the power of 500 universes, all sterile, except ours, but this is the fine-tuning for physics, but you have to add, as Michel-Yves said, a fine-tuning in biology. So what can we think about this kind of figures? In fact, if you want to look at this, we are speaking of 10 to the power of 500 universes like this, and why not? In fact, if I ask you to count to 1 billion with one number each second, night and day, you will have to count during 30 years. And if you have to count to a billion of billion, you will need 2 times the length of the universe. And if you count to 1 billion, billion, you need 2 billion times the time of the universe. So the question is it reasonable to say that you have to count to 10,000 billion? The first one. You see, this figure is absolutely crazy. So if you want to keep a materialist attitude, vision of the world, you need to believe that it exists in real somewhere, this number of sterile universes. Oh, okay. Is it reasonable? Not sure. But last but not least, there is even more important problems. Because if you have to select all the parameters of the universe in a very tiny range, the natural process or the machine, if you will, that creates universes must itself be fine-tuned. This video explains it very well. It's not possible for a natural process to choose the value of the parameters of the universe between 0 and infinity. So you have to target a certain range. And the right value of the constant should be in a very tiny range. And if you have a particular window, the machine should be very precisely adjusted. So the machine should be fine-tuned, but by whom? That's the reason why Stephen Hawking declared that the multiverse theory was dead, because it needs another fine-tuning for the machine. So for me, it's a very strong argument against multiverse. And in the same time, he said, Hawking, that the theory of everything, which imagined that all parameters of the universe are tied together by a meta law, and to allow no other value than the one they have. It's really very difficult to sustain. In fact, you imagine that the gravity has this value and it cannot have another one for a special reason deduced from a meta law. So it does not work. All this is problematic, as Lee Smolin, Paul Davies, and many others said, and a large number of cosmologists have worked on string theory over the past 40 years without convincing results, but with a great imagination and a great creativity. But at the end, many people say, is the multiverse really an explanation or a desperate answer? So apart from this highly speculative hypothesis, there is nothing else at this time to attempt to explain the fine-tuning problem. And a part of the, so this is a big problem, but regarding the beginning, it's exactly the same. Several solutions have been proposed, but none of them are convincing either. If you imagine an infinite amount of time in the past, you will have an infinite number of cyclic universes, an infinite number of Big Bang and Big Crunch in the past. But in fact, it does not work for 4 reasons. First, the entropy should be at its maximum, which is not the case. Second, black holes should be very numerous, which is not the case also. Third, the cosmological constant should have been dominant after a few cycles. And 4, finally, the universe might not be homogeneous and isotropic as ours is in fact. After 7 or 8 cycles, it will look like a cigar. So there is nothing very strong for explaining the beginning, and people try to have some other theories. Lawrence Krauss introduced the very mediatic but not very serious idea of a universe created from nothing. but what he calls nothing is something. It's absolutely not nothing. You have other people saying that all this comes from a quantum fluctuation to explain the beginning, but it cannot be the beginning because in order to have the possibility of such an event, you need that space already exists. And finally, Stephen Hawking from Cambridge once imagined that because there is a law such as gravity, the universe can and will create itself from nothing. But our friend John Lennox from Oxford replied, nonsense remains nonsense, even when talked by world-famous scientists. At the end, none of these attempts work, and this must be taken into consideration. What remains then? We are pointing in our book the astonishment of the greatest scientists regarding the discoveries of modern science, and it's amazing. We gathered quotes from 110 top scientists, including 63 Nobel Prize winners, to observe that some of the greatest scientists, often agnostic or atheists, spontaneously talk about God, miracles, or astonishing coincidences when describing the incredible settings and complexity that allows us to exist. Nobody puts a gun on their head, forcing them to talk about God, miracles, or coincidences. They did it because they could not do otherwise. Let's remember, as an example, Fred Hoyle. It's a typical case. He was the teacher of Robert Wilson, who wrote the first preface of our book. At the beginning, Hoyle was an atheist, and because of this, he fought against Georges Lemaître, and he coined the term Big Bang to mock the concept. Yet he converted later, becoming a believer, because he discovered that the triple alpha reaction that enables carbon synthesis in stars would be impossible without an excited state of carbon at a very precise energy level, unknown at this time. He concluded that a super intellect deliberately designed the laws of nuclear physics. A little later, Robert Dicke was the first to mention at Princeton another incredible fine-tuning that of the initial expansion rate of the universe, which had to be accurate to 15 decimal places. Otherwise, we will not be here to talk about it. And he was very surprised of this, of course. And a lot of scholars of Berkeley also speak of these incredible coincidences. For example, Charles Townes, for example, he speaks of this intelligence that must have been involved in the creation of the world. Or George Smoot, who explained that the Big Bang was precisely orchestrated and the symmetry and the order was absolutely beautiful in the beginning. And he spoke of those anisotropies that allow the universe to exist. The difference of temperature, the universe is very homogeneous, but the difference are exactly what we need to have galaxies, stars, and life. And if the improbability is is great. So we have dozens of examples like these in our book, many in physics, of course, but a lot also in biology. And the conclusion is simple and always the same. All the parameters that determine our world are unbelievably adjusted and calibrated, and that inspires wonder. I have two examples that I like especially. One, perhaps the greatest fine-tuning of all, presented in 1989 by Roger Penrose, who hopefully will be with us in Cambridge in November 21.
Oxford in January 24. Penrose is Oxford.
Ah oui?
Oui.
Okay.
January 24. Oxford.
Okay, I think I thought he will come in Cambridge. He calculated that to start off the universe in a state of low entropy required for galaxies, stars, and life to exist, the creator had to aim the distribution of energy and mass at the origin of the universe with an accuracy of 1 part in 10 to the power of 10 to the power of 123, which is, of course, a mind-blowing precision. And as we saw this morning, here in Berkeley, with Saul permuter, we have to we remind that there's other incredible fine-tuning, which is that of the cosmological constant. Saul permuter revealed in 1998, together with Brian Schmidt and Adam Riess, that after 8 billion years, the expansion of the universe began to reaccelerate, which means that there is a cosmological constant in the Friedmann-Lemaitre equations. In those equations, the last term dominates now, and the value of this term is the one you see there. And if the last three figures were displaced for two range, if they were 10 times more, we are not there to speak of this. And it's totally incredible because this figure is 120 order of magnitude below what we were expected with the models of the physics of particles. So it's an incredible fine-tuning, a mystery for the physician. And the question is, can we explain this by chance? In fact, it's clearly impossible to explain all the fine-tunings by chance. If you win the lottery every Sunday during 1 year, it's not by chance. There is something. The police will come and tell you that you are cheating. And if you say, no, I have chance, we need another explanation. If you play dice and you roll double six 10 times in a row, it's the same. It's not possible. It's not chance. It's a specific order. And for having a specific order, you need an explanation, not chance. So, and if you throw Scrabble letters in the air and that the lineup, it lines up in a correct sentence, but also express something beautiful, not only correct sentence, but something beautiful, because in the universe you have not only the fact that it works, but it's beautiful. It's absolutely not possible by chance, of course. Okay, for all those reasons, after investigating also the fields of philosophy, morality, and history, it seems that the thesis of the existence of a creator God is more convincing than ever. Yet there is a great reversal, especially in science, but we are not the only one to say this. A lot of books and publications say the same. We have those ones, but also those ones. Okay, a lot of books and publications. And the problem is that the public remains largely unaware of this. And what should be done then? As Michel-Yves said, it's a very sensitive, passionate, and emotional subject. So in our book, we wrote a chapter to show how the scientists who discovered the Big Bang were violently persecuted by an atheist regime in Russia, Germany, and even China. And there is ideology, and there is also today ideology and obstacles to an honest debate. For example, in our time, George Wald said that we cannot accept supernatural creation in philosophical grounds. And Richard Lewontin said we have a prior commitment, a commitment to materialism. So when you have this kind of attitude, of course, it's difficult to have a dialogue and with the people. But we have to try anyway. Our goal with this book, with meetings like this one and the other ones, we would like to have a broad debate on these new questions. We think it's necessary, and this is the purpose of the release of our book in the US in October. In conclusion, I would like, we were in Princeton last week. I would like to remind you of this story that took place in 1933 in the room where we were in the room where Einstein was teaching. And in this room, probably, a young girl went, and a sixth grade student named Phyllis Wright managed to pass him a letter with this question: do scientists pray? And Einstein was a bit surprised, of course, but about 10 days later, the little girl received from him a letter which is now famous in the whole world. He wrote in German, everyone who is seriously involved in the pursuit of science becomes convinced that some spirit is manifest in the laws of the universe, one that is vastly superior of that of man. This is, in fact, a very powerful idea, an idea that Einstein was the first to express a few decades before the discoveries of the many fine-tunings of the universe. To finish, let me thank you for your time. It's really a great honor and a great joy to be standing with you all and talk of all those passionate issues, as we said, here at Berkeley after Princeton and in such impressive places. Thank you very much.